Hello, everyone. This is the presentation for scaling up Utah's automated manufacturing technician pipeline, also known as
SUUAMTP.
SUUAMTP. Sorry for the acronym. Before we move forward, we'd like everyone to know that this is funded through the National Science Foundation grant. It was an ATE grant that started in 2018. Here's our team. My name is Mason Leffler. I'm the PI on the grant.
I'm Matt Fuller, and I'm the co-PI.
And Scott Danielson will be talking later. One of the issues that we're facing in the nation right now is the fact that there is not enough technicians for the amount of manufacturing jobs in automation. In northern Utah, there's an extreme deficit. We have a ton of manufacturing happening, and all of these companies are automating their manufacturing lines.
And hundreds of millions of dollars are being spent in northern Utah alone to automate everything from ice cream sandwich lines to airbags, all sorts of different things.
To cow milking.
Yeah, cow milking, all sorts of stuff.
All sorts of stuff. Just to give you an idea, when we first wrote the grant, we found out that there were approximately 630 jobs that were available for techs, manufacturing technicians, and that we were producing across the state about 21 per year. And that's just not enough. One of the other issues that we're facing with trying to produce enough manufacturing technicians is that these skills, there's not a lot of people that have these skills to teach others on how to do them.
Not at the high school level, not at the university level. In fact, we had employers searching diligently, and they were hiring completely outside of our state. And the problem with that is, as they brought people in who didn't live here, they would live here and work here for a short period of time and then go back to the state or the place where they came from. And so they were having difficulty keeping the people they were able to recruit, which is another part of that huge bottleneck problem.
So this was as we were thinking about how to scale and how to get more students into this pathway and this pipeline, that was one thing that we had to try and think our way through, is how do we distribute the expertise when there's only a few people in the state that have these skills, or at least that are teaching them. Another issue is that if we're going to scale and you've got just a very few teachers that are teaching this content, how are they supposed to train that many students? And that was another issue that we had to work our way through.
I had, for example, 21 courses assigned to me at one point, and just with the technology advancing as rapidly as it does, it just was nigh on impossible for those of us that did have some expertise to even keep up with what it was that we had on our plates.
Another issue that we had to trying to think our way through was the fact that K-12 education has one single focus on moving students through to the university, and yet these skills aren't taught at the university. And so we needed to figure out a way to get people moving in this direction.
Part of that problem, too, is that public perception is a huge issue for the technical, in the technical arena, and especially when it comes to skills acquisition and those sorts of things. And when and most parents and most of our population thinks university before they think, say, technical college or something like that, despite the fact that there's huge opportunity for our students to immediately get to work and get to work at very, very high rates of pay, and the need is tremendous.
The graph here is really interesting because when we looked at it, we asked local companies, and we also did our due diligence in figuring out how many techs are needed in comparison to engineers. And for every engineer level, we need 7 techs, and the techs are able to go through get our certificate in a fourth of the amount of time, much less cost, and almost rival the pay in some cases.
In some cases, it surpasses it, actually.
So in a nutshell, as we were thinking about how to scale, we really had to think about how do we alleviate this minuscule pipeline, how do we overcome those expertise bottlenecks, how do we develop curriculum fast enough for a sector of manufacturing that's just under constant revolution. How do we replace a workforce that's retiring? And then how do we get more K-12 teachers looking in this direction? So in 2018, starting in 2017, we started the process of writing a National Science Foundation grant, and we had 4 major objectives in curriculum, recruitment, retention, and professional development. We wanted to take at least 10 of our courses for our automated manufacturing certificate and our electronics engineering certificate, and make those courses available at a distance at high schools, but at the same time, not dummy them down, keep them hands-on, keep them fun and engaging. We also needed to get more students in the pathway. We set the goal of increasing by 50 per year by our 3rd year of the grant. We also wanted to reduce the amount of attrition that we were having. We wanted to make sure that we were retaining the students that we were getting in the pipeline, because some students were coming in at the high school level in their junior year, and throughout the year sometimes we'd have some attrition there, or by the time that they were seniors.
Well, and we were having on the retention side, on the recruitment and the retention, the recruitment side, we had very few high school students even coming to Bridgerland, even though we offered that to high school students all day long during the day, and then also during the summers. Very few, like 10 a year is what we were kind of getting, something like that. And then from a retention side, those high school students that we were getting for the entire technical college system, that was only something like, what was it? The 0.5% or something were actually going on to complete a certificate later on. And so we wanted to, by increasing the pipeline just in general, getting more students involved, and then retaining those once they get in. That was a big part of what we were trying to make happen.
And then we also wanted to, maybe this is a good time to kind of talk about the philosophy of the AM STEM Academy. The idea in a nutshell was that we would use high schools and the teachers there to teach our curriculum at a distance.
So they became facilitators on the other end of a live broadcast every morning at 7 in the morning. And those teachers, from a recruitment standpoint, become our number one recruiting person, because every high school teacher has got a circle of students that they influence on a regular basis. And so they have the ability to get more, see these high school students every day and get them, the ones that seem like they would have a good aptitude for it, into the program. And then the other part was we couldn't duplicate ourselves, and we couldn't hire people enough. We can't even find enough people with the expertise that we have at our school to be able to try to teach all this stuff at every high school. And so what we did was we said, let's bring these high school teachers in, CTE usually CTE high school teachers, who are our facilitators, and have them go through the curriculum and help us facilitate that curriculum by actually learning it themselves. And so for 2 weeks every summer we bring them in, and then we use our broadcast system throughout the rest of the year to connect the spaces and kind of continue that in that professional development in real time. Every morning at 7 in the morning.
We really needed to figure out if we were going to keep this hands-on and at a distance and kind of build out a classroom at each of the local high schools, we needed to have technology that was cost-effective.
Yeah, that was huge. We wanted to maintain a 75% hands-on standard for our curriculum, so that the students were getting real-world experience on real stuff, on equipment that they would actually see in the real world, and do that at a distance. And we were told numerous times that wouldn't be possible, but then we turned around and did it anyway.
So for the rest of this presentation, we're going to dive into each of these areas: curriculum, recruitment, retention, and professional development, and talk about some of the things that worked and some of the things that didn't work. With those 10 courses, we wanted to make them more competency-based. We wanted to produce more video lab demonstrations, and we also wanted to have stronger rubrics so that the teachers would be able to facilitate it much easier at a distance. Just to give you an idea of some of the courses that we were planning on working on, these are the courses. You can read those if you'd like. And just to give you kind of a juxtaposition, the old model that we have was really, the content was, it was lockstep, you know, and that wasn't going to work.
The very first year that we started this, I actually tried to do it lockstep, and it failed miserably. In fact, we had one of our high school facilitators about a month and a half in call me and say, Matt, would you just stop talking and let these guys work? And so we learned that we needed to make this more self-paced and competency-based. And we are 100% competency-based. In other words, if a student doesn't hook something up correctly, then they do it again. If they are missing some information on something, then they do it until it's done correctly. And by making it self-paced and allowing students to start and stop in the program as they need to, it has made it possible for certain students to complete certificates while they're still in high school. In fact, a full 900-hour certificate that way. So that one's kind of a big deal. That very first one,
and that's a huge undertaking.
Yeah, huge.
Going when you have control, you're basically demonstrating everything live. You're giving instructions live. But once you decide that you're going to make it student-paced, you have to take all of those lectures, you have to take all of those lab models, you have to have all of that inside of Canvas and at a level that's robust enough that nobody's going to have any questions.
So, that brings up an interesting question, Mason. If it's going to be that much work, why would someone else want to do that? And I can tell you one of the big ones for me has been, we did do it, and we keep doing it. We keep changing our curriculum, getting all of the lectures and any demonstrations and anything pre-recorded, so the student can go through them at a slow or a fast pace, whatever they want to do. We see a lot of students that'll crank our videos up to like 1.5 times its speed and that sort of stuff, and that's all fine, but then they can rewind and go back and watch it again and do what they need to do. Why go through all that effort? I can tell you that now that it is basically done, it saves me a tremendous amount of time, and it's easier to grade. And another big part of it is I enjoy going one-on-one with students much more than I do standing in front of them and lecturing, or some of those lectures are kind of fun, but I feel like you get to a point where you're on repeat. And I feel like I'm able to go one-on-one and really find where students are missing learning and really help them, and I love that. It's so much fun.
There's a bit to say about accessibility.
Yeah.
If everything's closed caption, then students are able to watch it at whatever speed, but they're also be able to read it. And I think that's really powerful as well.
Well, and all students start at a different spot when they walk into class, right? And some may have a really deep understanding of something and can breeze through stuff really fast and then get on to the next thing. So they don't get distracted and start causing, we have hardly any disciplinary problems. I mean, next to zero. And because the students that have the ability to run can run. And those that need to slow down can slow down. And some people see it as chaos. We love it. It's for us, it's great.
Just to remind everybody about the professional development. So as Matt mentioned, we have a 2-week summer camp for the teachers where they come in and spend all that time with us. We also do curriculum sharing. And inside of the curriculum, we've built helps, and we'll kind of talk a little bit about that. And then we also have an annual leadership meeting. And those were all the different supports that we were able to do. The annual leadership meeting was for teachers or for tech college faculty across the state or university level faculty that were trying to duplicate our model in their area, because that was a big part of this grant as well.
We kept getting them. They kept all coming. In fact, we've had people from other entities outside of the state that heard about what we were doing, that have spent a lot more money than we have, asking how in the world are we getting this many high school students to look in this direction, and how are we accomplishing what we're doing. And so we decided to start having this leadership meeting to kind of get everybody in the room, so we don't have to keep answering these questions over and over again, and then get their feedback too. And we wanted it to become a collaborative thing, because we didn't want to be the only ones building this curriculum and taking all the time to do that.
Initially it was a lot of sharing out, and we're getting to the point where people have been doing this for a few years. They've taken our curriculum, they've iterated, they've built out things and maybe done things that we haven't done. And that annual leadership meeting gives us an opportunity to sit around a table, talk about what's working, what's not working, and share.
Yeah, it was really cool to see one of the teachers at one of the other tech colleges really run with that, and to go visit him and see all the things that he had changed that we hadn't even thought of. It was great. It was really neat.
Just to give everybody an idea of what we were able to accomplish, we this little simulation will kind of show everybody by year how much we expanded. So in the first year, we started with our 2 locations and about 8 schools, and then expanded a little bit in our area, and then helped out Tooele Technical College and West Wendover. Then in year 3, we helped out Davis Technical College and Utah State University Eastern.
Kind of see them down the bottom right. That West Wendover, they're clear over on the left-hand side of your screen. That little red dot over there, out in the middle of nowhere. And a cool little school, reservation school, and it was really neat to see how they were able to respond to this curriculum and the access it gave to this little tiny school. We also had the same kind of thing happen in the upper right-hand corner dot. That's Rich High School, which is another school, very, very small, that's out in the middle of nowhere. And those students were able to get access to some of the most advanced technology, technical systems in our curriculum, and at a very low cost.
And something that they would have never had the opportunity.
Never had the opportunity because they didn't have the expertise. The teachers there would never have had the expertise to do it.
And something that rural schools just miss out on.
Yep. That's kind of a cool byproduct of what it is that we've done there, is that small schools can have access, and can have the expertise and the help from experts like myself and others and other instructors who would never be able to make it out there otherwise.
One of the things that we did when we were sharing out the curriculum is that when we first initially said, "Oh, well, we'll build some resources or a guide on the side that people can use," and quickly we realized, well, why don't we just throw this into the Canvas courses that we're sharing out with everybody? And what we did, one of the cool things that we did, is we just built these facilitator help pages within each course so that everything was nested right where we wanted to give the teacher hints and helps. In most cases, we didn't have to do a lot of this because we just made sure that the rubrics and the instructions were really tight. And when you have the lab demonstrations, the teachers are able to get the gist of what's happening. Speaking about the high school teachers.
Well, we've found this to actually be really helpful internally inside of our own program, because I have expertise in certain areas and other instructors have expertise in other areas, and their courses that they've built may have certain things in them. Well, when they're not there and I'm trying to help a student with their class, I can go to the facilitator help page and figure out what the expectation is. And those facilitator help pages in Canvas are unpublished so that students can't see them, and only the teachers can.
Yeah, that was really helpful. The other thing that was really nice about us sharing curriculum is that luckily everybody in Utah and Idaho, at least all the public institutions, have adopted the LMS Canvas. And that's not necessarily an endorsement, it's just the fact that everybody's on the same thing. Yeah. So we could easily share curriculum with other institutions. What we did was we created a closed commons consortium, and when somebody came to us and said, hey, we'd like some curriculum, we had them sign an agreement that they would adopt and adapt and share back, and also participate in that leadership and meeting annually. And that was a really easy way, and every year we just upload the next versions of these courses, and those other schools are starting to upload those versions of their courses, and it's a really nice way for teachers to be able to have access to all that curriculum and immediately pull it down. I mean, it takes a few minutes to have a whole course that if somebody was starting from scratch, you'd have to spend a billion years doing yourself. So one of the things that we mentioned at the beginning is that low-cost training equipment was absolutely, totally key, and this was one of our most innovative aspects of the curriculum to ensure that we were able to scale at large. We've produced a little video that we're going to share out through ATE Central that talks about the various versions of these trainers that we've used.
Hi, I'm Scott Danielson, and I'm with the Automated Manufacturing Department at Bridgerland Technical College. The curriculum that we've created is centered around, much of it is centered around trainers that we've put together, and we've changed how they look and how they're used over time. So one of the challenges we had in rolling this curriculum out to students at high schools was equipment. We had to have equipment at the high schools, and all of the options that were out there were way too expensive. You know, you buy one of these off the shelf, some type of a training system, and they're thousands of dollars. So we came up with a low-cost training system that we could have at the high schools. This was our first version of it. It's basically rails with a power supply, a 24-volt AC and DC power supply. And then we've got components that we were able to just put onto these DIN rails and use them to deliver our curriculum. And the students would be able to be hands-on even though they weren't present at Bridgerland. We were taking Bridgerland and bringing it to them. This is an example of a relay that is made to snap right onto a DIN rail, just like this, right? And then we've created things like these button boxes. They're full of buttons that students will wire things to. And on the back, we've put DIN rail clips. And the DIN rail clips, of course, allow us to snap that right onto a DIN rail. We've created many different courses that use this. And what we have is all the parts that are needed for that course are collected into a bin, or just a collection of parts that the student needs in order to complete the course. So this is a DIN rail as you would buy it from an industrial supply store. Again, it's a very standard piece of equipment. It's readily available. They come in about 6-foot pieces. So you cut these to length, and then you can mount them, in this case, onto a vertical plate. You make sure you put a screw on either end, and then put some screws in the middle, just so it's nice and tight against the back plane, so that the students can remove parts from this without pulling the DIN rail off. Now this is our first iteration of this training setup that we did, and we've got 3 rails here, and we've also got a power supply that we've wired up to this terminal block, and it's on a rolling cart. And we realized soon after we made those that we can use low-cost 24-volt DC power supplies for our labs, and these are also DIN rail mountable. So we just snap that right on the DIN rail, and then once we realized that, we realized that we could put this DIN rail pretty much any place, and we've changed the configuration of how we do these kits for training as we moved forward. So what we have here, this is just a piece of wood that is given some legs. We attach some legs to it, and it's just a desktop model of the same thing that we had on a rolling cart. But this can sit on any desk. It's very lightweight, and all it's got is 3 rails on it, and that's it. And that's all you need now, because all of our kits include, in the list of parts, it includes the power supply that we'll need. So students will just snap all the parts that they need onto here, do the course, and then they can take it all off and return it to the kit. After that, we realized, well, if we've got wall space, we can put DIN rail all along the walls. And we've done that here at Bridgerland Technical College. On all of the walls in our automated manufacturing department, they're covered with these DIN rails. So students can take this curriculum pretty much any place that we've got rails, they can sit down and go to work. This is our latest iteration of what we've been doing. So it's got a couple of pieces of DIN rail here on a back plane that is actually a cutting board. It's a vinyl cutting board. And we've mounted all of these parts to this, and it's not meant to be removable in this case. Students now can take this very compact thing, and what we're looking at here is actually all the parts that are needed for our PLC-1 course. So a student can take our entire PLC-1 course on this small little board. And here in front of me are some parts, other parts that you may need that are not included in all the kits. One of them is, this is a digital multimeter for measuring voltage. And here's, this is also a digital multimeter. It's a little bit of a cheaper version, but they're both made by a company called Greenlee, and we can recommend those. This is an amp meter by HI-TEC that is used in the basic electrical course. And then your students are going to need tools like wire strippers, screwdrivers, and this is a smaller screwdriver for mounting wires to terminal blocks. This is a safety kit, a lockout tagout kit. So for this, we teach students how to lock and tag out electrical equipment just like they would do in industry. We have locks, tags in that kit right there. And then lastly, for helping communicate and to record videos, students would need a camera attached to their computer. And this is a couple examples. This one's by InSwan, and it's about $100. And this one is by IPEVO. It does exactly the same thing. They connect via USB port and allow the student to have a way to communicate to us through video. So those are some parts that students will need to be successful in these courses. That was a quick rundown of the physical trainers that we use to do our classes here at Bridgerline Technical College. We hope that we've created something that's very useful for you and very useful for the students. Thank you very much.
So that gives you an idea of some of the equipment that we've been using over time. Different high schools are using different configurations.
Yep.
And that's
what's nice about it.
Yeah, that's what's nice about it. Some people are throwing it up on the walls if they've got a room that's dedicated. In some cases, people are still using the rolly carts and they're rolling it in and out of the room if they don't have a dedicated room.
Our cost savings was substantial compared to buying this from like an education provider or something like that. It was significant, and this is what actually made it possible for us to put physical equipment in at every high school.
So next we wanted to talk about some of the few things that we did in order to retain students throughout the year. Each year we would do some tours at industry. This is one picture of about four pictures. We had over 100 students that we took through Autoliv, which is the largest manufacturer in Utah. We would also do an automation competition and a job fair. A lot of this stuff we haven't been able to do since 2019 due to the pandemic.
But it is scheduled now, so we are very excited to get back out there and introduce students to employers at a much more interactive level.
Yeah, in addition to just making the curriculum hands-on fun and doing some of these fun activities, one of the really important things that we'll have Matt talk about is really disconnecting these pieces of education.
So Autoliv is the largest manufacturer in northern Utah, and only maybe a tenth of our students, that includes adults and high school students, even know who they are. It's fascinating how, and most of our employers are like that. Because of the public perception of manufacturing in general, they just don't even know who the big companies who they are and what the opportunities are with them. So going on tours, introducing them to employers at a special career fair just for manufacturing, doing those things introduces these students, and all of a sudden it opens their eyes. And for example, at that Autoliv tour, we had numerous students that would come back and say, I know what I want to do now. This is cool. I want to do this, right? So just wanted to mention that too. It's huge. It's very, very valuable.
I mean, it's just amazing. You walk into those places and you just don't, it's so high tech. It's just like you're blown away about how this stuff works. And it's really exciting to see. So talk to us some about the stackable credential pathway and why that was important for retention.
So first of all, there was a huge disconnect between our high schools, our technical college, and the university. We did have an associate's degree that any 900-hour certificate or higher would stack into. But when we first started a lot of this, we didn't even know who our high school teachers even were. There was really not much of a connection there. In fact, if anything, there was a little bit of butting heads where we were kind of felt like everybody was competing for students,
CT students, right?
Yeah, and so there was this AAS associate's degree that kind of went nowhere. That our certificates could stack into, and then we really didn't have much of a pipeline coming from the high schools. So we were able to, with cooperation between our local university and us, we were able to get a bachelor's degree that could stack into an associate's degree, and then stack back to our technical certificate. And then thanks to this program, we were able to get our certificate taught in the high school with the help of our teacher facilitators, and that kind of connected all the pieces, and so that was all really important. But the most important piece to the whole puzzle here was making sure that industry was involved the entire way, and so they are the centerpiece. We meet with them every 6 months. We have a strong, robust advisory committee, and that's a whole nother conversation. About making sure that you have strong people people with influence, people that can actually make decisions and help place students on your advisory committee. We did a lot of work there as well, and those people are telling us this is what the skill sets they need to come out with. They help us with our career fairs for the high school side. They help us with our curriculum on the technical college side, and then they hire our students at the associate and bachelor's degree levels at very, very high rates of pay. It's awesome.
Since I've been on the project, not once have I had a conversation with a teacher or student where I explain the stackable credential pathway, which is really essentially dual enrollment, right? Mm-hmm. High school students are getting credit both at the high school as well as the technical college, and so long as they finish our certificate, they're also getting, it's almost like triple credit that they're getting for that 1 hour a day that they're spending with us.
They're getting so that 900-hour certificate that can get 30 credits towards that associate's degree upon completion. That's the equivalent of about $10,000 that they're saving themselves, and they can do our certificate while they're in high school for free. So all we do is make the argument. It's not like we just show them the opportunity, show these high school students the opportunity. The smart ones take advantage of it. And the really smart ones will get in and buckle down and get it done. And so it becomes a kind of a natural filter for our employers as well. Those that don't have the work ethic to get the thing done just don't end up in industry. And those that do are able to make some amazing things happen for themselves. And what's really cool is we're at the point now where it's kind of that tipping point where the older brother, the uncle, the older kind of group that started with us years ago, they're making really good money now, and as they are talking to their brothers and their sisters and their nieces and nephews and other people and family members, the word's starting to spread, and it's getting easier and easier to show them the opportunity.
So when we talk about recruitment, some of the things that have been working really, really well, I'd say number one, like you mentioned before, is using the high school teachers as recruiters.
Yep. Empowering them, giving them the tools they need to showing them the opportunity, getting them on board, taking them on industry tours, helping them to get to know local industry, and then they just talk about it.
They spend years with those students, and they have hundreds of them coming into their classroom every year. They know who's going to do well in this direction, and they can share that story and get people moving this way. Another important thing is we would make presentations out into the high schools, and then we'd also go to conferences and do presentations. Like, for instance, every year we'd go to the HI-TEC conference here in the state, which is a statewide conference for girls that are interested in STEM. We'd also have a career day here where we have thousands of middle school aged kids that are about to go into high school that would come, and we would present to them as well.
One of the things we really wanted to do was make sure that our high school teachers and anyone who was doing this, could be administration, anybody who was helping us get the word out about this, that they would have some tools to help with recruitment, with even with retention a little bit, to help our high school students understand what it is that this stuff is. We searched and searched for videos that talked about what it means to be a maintenance technician or controls technician in real life, and couldn't find any. And so we thought, okay, we need them to be able to see what this is. We wanted them to be able to kind of tour a plant and see a plant. And when COVID hit, the idea came up, why don't we just make a video for this so that we can show it anytime, anywhere. It's not quite as good as going on site and actually seeing it in real life, but it is very helpful as a recruiting tool and as a retention tool, in that it helps students understand what this is and helps them determine whether or not they should So this is something they want to continue to do.
My name is Britt Stacy. I work at Casper's Ice Cream, and I went through the automated manufacturing program at Bridgerland. I'm a maintenance technician on grave shift. I go through all of the equipment, make sure it's running 100% for maximum efficiencies.
My name is Sean Anderson. I am the plant engineer at Casper's Ice Cream. We are a manufacturer of ice cream novelties. Our biggest product is the Fat Boy ice cream sandwich. We also make stick bars, ice cream cones, tubs of ice cream, cups of ice cream, all kinds of stuff. Britt is one of our mechanical or automation technicians. Each day he is tasked with helping maintain and keep our equipment running. What that means can really vary a lot from day to day.
We usually don't have a set schedule for the day, but my first thing I do when I come in is I grab my tools, I go out to the production floor and make sure everything's running smooth, make sure there's no problems anywhere, and then I do my walkthrough. So I'll walk through the building, just making sure everything's running smoothly and where it needs to be, nothing's out of place. Usually the 30-minute overlay with other technicians, they'll tell us any problems, big problems, small problems, pretty much anything that they can remember from what happened on their shift, so we have the knowledge just in case it happens again, or if we need to further do any more work to what they've done. Every Friday, we make sure everything is ready for Monday, so any of the problems that production comes to us with, we'll usually fix on spot, and they usually have, just the basic sensor problems, jam ups, maybe bent like buckets or slats or different objects on the equipment.
As I've worked with Britt, what I've loved is his openness and willingness to learn. He definitely has the foundation knowledge that he needs to understand what we're talking about. And he is just always open and excited to get more information, gain more skills, and contribute more to our company.
What I think is cool about working at this industry is all of the high-tech robots and all of the moving parts and all of the fancy equipment that are out there, and being able to actually get my hands dirty and work with them and fix things on it, and having that satisfaction of, hey, I fixed that. The skill sets that I've learned with the growing industry pretty much guarantees me to have a job.
I hope that people understand that we are looking for technicians that have training and skills and education that are going to serve us in our industry, and that these positions aren't going anywhere.
In addition to giving people an idea of what a manufacturing facility looks like right now, it's also a student success story. It's also talking about job duties. It's also giving them an idea of the types of work ethic and those types of.
Will I have a job in the future? And you heard Sean say,
yeah,
it's absolutely, absolutely. There's so much happening in this industry. So, yeah, pretty cool stuff.
So just to sum up, with respect to curriculum development, we were able to take 10 of those courses and make them available at a distance. Our recruitment went way up. We're about to finish up our year 3 in a week or so away from now, and we'll have the results of year 3 pretty soon. We're pretty positive that there was a drop off
Because of COVID.
Yeah, due to COVID. We already surpassed our goal in year 1. In terms of retention, we're retaining over half of the students. Half of the seniors that are finishing each year are coming back into the full-time program.
Yes, we had a dip in COVID, but and I don't have numbers for this yet, but I can tell you that we are hitting critical mass. As soon as the COVID restrictions were lifted in our state, for example, our high school summer program, we just set records with the number of high school students that started with us for our summer program, and I'm anticipating that that's going to be similar in the fall.
And if you're interested in learning more about this, or perhaps coming out and going through some of the curriculum, that's one of the things that we found was most effective, that if somebody wanted to take our curriculum and just take it without really going through the courses, that didn't help. But if somebody came up here, went through our certificate, as we had a few faculty, tech college faculty, as well as high school teachers that would come during the summer and go through the curriculum, and then they would be able to really, they just got it by then. When they went back to their institution.
When they went through it with us, those that built the curriculum in the first place, they could ask all the questions they wanted, and then when they went back to go to facilitate it or improve upon it, they hit the ground running. It actually worked really well that way.
So if you're interested in being a part of this consortium, if you're interested in the curriculum or some of the resources, please reach out to us. We're more than willing to help anybody out, and we'd love to learn what you're doing in your area.